Here's something that surprises almost every team I work with. Surveys of enterprise leaders keep showing that well over three-quarters of organizations are already using AI in some form. Yet only a small fraction have any formal AI risk process behind it. So the technology is inside the building, making decisions, and nobody has written down what happens when it gets one wrong. Let me ask you something. If your hiring tool quietly filtered out qualified candidates for 6 months, when would you find out? Most organizations honestly don't know. That's not a technology gap, that's a risk management gap. So, what are we doing in this chapter? We are going to build your foundation. You'll walk out understanding what AI actually is, how it differs from machine learning and deep learning, where it's already creating value across industries, and why AI risk behaves so differently from the IT risk you already know how to handle. We'll look at real failures, real regulatory pressure, and real business consequences. Think of this chapter as the why before the how. Everything else in this playlist, all four functions of the framework, all seven trustworthy characteristics, rests on what we cover here. Give me the next few videos, and you'll be able to explain to your board in plain language why AI needs its own risk framework and why the old one won't stretch to cover it. Let's begin. Before we dive in, let me walk you through the journey we are about to take together so you know exactly where we are headed. We'll start with the foundations, what AI risk actually is, and why managing risk in AI systems is fundamentally different from anything you've dealt with in traditional IT. From there, you'll meet NIST itself and understand why its voluntary framework has become the reference point for AI governance around the world. Then we get into the heart of it. You'll learn the framework's two-part structure, the AI lifecycle, and the seven characteristics that define trustworthy AI, from validity and safety to fairness, transparency, and privacy. We'll break down how AI harms show up at the individual, organizational, and societal levels, and why measuring AI risk is so challenging in the first place. The core of this series is the four functions that make the framework work: govern, map, measure, and manage. We'll spend real time on each one: how you build governance and culture, how you discover and register risks, how you test and evaluate your systems, and finally, how you treat, monitor, and respond to risk once a system is live. And we'll close by looking ahead at profiles like the Generative AI profile, how the framework connects to ISO 42001, the EU AI Act, and the cybersecurity framework, and where AI risk management is heading next. By the end, you won't just know what the AI RMF says, you'll know how to put it to work. Let's get started. So, what is artificial intelligence? You'd think that's the easy question. It's actually the one people fumble most. NIST gives us a working definition. An AI system is an engineered or machine-based system that, for a given set of objectives, generates outputs such as predictions, recommendations, or decisions influencing real or virtual environments. That's the official language. Let's break it down in simpler words. Three ideas are hiding in there. One, it's engineered. Somebody built it, chose its objectives, chose its data. It didn't appear. Two, it produces outputs that influence environments. It doesn't just calculate, it acts on the world. Three, and this is the quiet one, for a given set of objectives, somebody decided what good means for this system. That last point matters enormously. Imagine a recommendation engine optimized for watch time. It does its job perfectly, and in doing so, it learns that outrage keeps people watching. The system didn't fail, it succeeded at the objective somebody handed it. So when you're assessing an AI system, don't start with the algorithm. Start by asking, what is this thing optimizing for and who chose that? 9 times out of 10, that's where the risk lives. And notice, nothing in that definition requires intelligence in any human sense. which is why we need a clearer vocabulary. That's next. Let's clear up the vocabulary because these three terms get used interchangeably and it causes real confusion in risk conversations. Picture three circles, one inside the other. Artificial intelligence is the outermost. It's the broad ambition, any system performing tasks we'd associate with human intelligence. That includes old-fashioned rule-based expert systems, the kind that were literally a long list of if-then statements written by humans. Inside that sits machine learning. Here's the shift. Instead of a human writing the rules, the system infers the rules from data. Show it thousands of past loan outcomes, and it works out the pattern itself. Your spam filter is machine learning. Your fraud alerts are machine learning. And inside that sits deep learning. Machine learning using neural networks with many layers, which lets it handle messy, unstructured things. Images, speech, language. The large language models everyone's talking about live here. So why does this matter for risk? Because opacity increases as you move inward. A rule-based system you can read. A decision tree you can follow. A deep neural network with billions of parameters? Nobody can trace exactly why it produced a specific output. Here's the practical takeaway. When someone says we're using AI, your first question should be, which circle? Because that answer tells you how hard your explainability and testing problem is about to be. Let me take you on a quick tour because I want you to see how far this has already spread. This isn't a future conversation. Start with banking. Every card transaction you make runs through models scoring it for fraud in milliseconds. Credit decisions, anti-money laundering alerts, algorithmic trading. Financial services was early and is now deep. Healthcare. Radiology models flagging findings on scans. Sepsis prediction tools watching vitals in ICUs. Drug discovery narrowing millions of compounds down to hundreds. I worked with a hospital group where the sepsis model genuinely saved lives, and the same model also generated so many alerts that nurses started ignoring it. Both things were true at once. Retail and supply chain. Demand forecasting, dynamic pricing, warehouse routing. Manufacturing. Predictive maintenance, listening to a machine's vibration and predicting failure weeks out. Then the workplace itself. Recruitment screening, performance analytics, customer service agents handling conversations end to end. So here's my question for you. Look at that list and count how many of them make decisions about people. Credit, hiring, diagnosis, pricing. That's most of them. That's why this matters. AI isn't sitting in a lab. It's sitting between your organization and the people it serves, and it's making calls on their behalf. Now, I want to be fair here. If all we talk about is risk, you'll walk into your business and sound like the Department of No. And you'll lose the argument, deservedly. So let's be honest about the value. AI creates returns in four ways, and it helps to name them. Efficiency. Work that took hours takes seconds. A claims team I worked with cut document review from 40 minutes to under 5. That's not a marginal gain, that's a different operating model. Quality. Models don't get tired at 4 in the afternoon. In pattern-heavy tasks like defect detection or transaction screening, consistency alone beats a fatigued human. Scale. This is the underrated one. AI lets you offer things you simply couldn't afford to offer manually. Personalized guidance to every customer, not just the top tier. 24/7 support in 12 languages. And new capability. Things that weren't possible at all. Protein folding, real-time translation, generative design. Here's why this matters for your role. Risk management is not the opposite of value. It's what protects value. Every one of those wins evaporates the moment a model causes a scandal, a regulatory action, or a lawsuit. So the framing I'd give you is this. We're not here to slow AI down. We're here to make sure it doesn't have to be switched off. Good governance is what lets you keep the upside. Alright, here's the video that explains everything that follows. What actually makes AI systems different? 5 characteristics. Let's walk them. First, they're probabilistic. Traditional software gives you the same answer every time. AI gives you a most likely answer with confidence attached. Ask it twice, you might get 2 answers. Your testing approach assumed determinism. It no longer holds. Second, they're data dependent. The system isn't just running on data, it's made of data. Change the data, change the system, which means your data quality problem just became your model behavior problem. Third, opacity. In complex models, nobody can fully explain a specific output, not the vendor, not the data scientist. That's uncomfortable when a customer asks why they were declined. Fourth, they drift. This one catches people. The world changes, the data changes, and the model silently degrades while still returning confident answers. It doesn't crash, it just gets quietly worse. Fifth, emergent behavior. Large models do things nobody designed and nobody predicted. So let me ask you, how many of your existing controls assume the system behaves the same way tomorrow as it does today? Most of them, right? That assumption is exactly what breaks. Let's look at that next. So let's put them side by side because this comparison is the one I'd want you to be able to draw on a whiteboard. Traditional IT risk. Failure is binary. The server is up or down. The transaction posted or it didn't. You detect it fast, usually within seconds, and the alert is unambiguous. AI risk. Failure is gradual and often invisible. Nothing goes red. The model keeps returning answers with high confidence, and those answers are getting worse. I've seen a model drift for 8 months before anyone noticed, and they only noticed because a customer complained. Traditional IT, you trace the cause, read the log, read the code, find the bug. AI, the cause is distributed across millions of parameters and terabytes of training data. There's often no single line to point at. Traditional IT, you fix it and it's fixed. AI, you retrain and hope, and retraining can introduce new problems you didn't have before. And here's the one that really matters. Traditional IT failures harm operations. AI failures harm people. A denied loan, a missed diagnosis, a wrongly flagged transaction. So do you see why bolting AI onto your existing risk register doesn't work? The failure modes, the detection methods, the remediation, all different. That's the gap NIST set out to fill. Let's zoom out and look at the landscape, because the risks are multiplying faster than most governance functions can track. Start with the classic ones: bias and discrimination. Models trained on historical data, learning historical prejudice, and then applying it at industrial scale. Privacy. Models memorizing training data and leaking it back out. Security. Adversarial attacks, where a tiny change to an input fools the model completely. Now add what generative AI brought. Hallucination, where the model states falsehoods with total fluency. I watched a legal team nearly file a brief citing cases that never existed. The model invented them, complete with plausible citations. Prompt injection, where an attacker hides instructions inside content your model reads. Deepfakes and synthetic media, intellectual property questions nobody has settled. And now agentic AI, systems that don't just recommend but act. They call APIs, move money, send emails. When a recommendation is wrong, a human catches it. When an agent is wrong, it's already done. So here's what I want you to notice. Each wave doesn't replace the last, it adds to it. You still have bias, and now you also have hallucination, and now you also have autonomous action. That's why a framework matters more than a checklist. Checklists date, frameworks adapt. Now theory is fine, but let's look at what actually went wrong for real organizations. These cost money, careers, and trust. The recruitment case is the one everyone knows. A large technology company built a hiring model on 10 years of past CVs. Those CVs were mostly from men. The model learned that being male correlated with being hired and started penalizing CVs that mentioned women's activities. They caught it and scrapped it. But notice, nobody coded that rule. The data taught it. Healthcare gave us another. An algorithm used to identify patients needing extra care used healthcare spending as a proxy for need. Sounds reasonable. Except historically less money had been spent on black patients for the same illness, so the model systematically underestimated their need. The proxy was the flaw. Chatbots have failed spectacularly too. Airlines held to promises their bot invented. Customer service agents talked into agreeing to absurd terms. Here's the pattern I want you to see. In almost none of these cases did the technology malfunction. The models worked. They did exactly what they were trained to do. The failure was upstream, in the objective, the data, or the assumption. So when you assess an AI system, look upstream. That's where the incidents are born. So regulators noticed. Let's talk about what's arriving and why voluntary frameworks suddenly matter a great deal. Europe moved first with the EU AI Act. Risk-tiered approach. Some uses banned outright. High-risk uses carrying heavy obligations around data governance, documentation, human oversight and testing, and penalties that scale with global turnover. Extraterritorial too, so it reaches you if your system touches the EU market. The United States has taken a different road. Less a single statute, more a patchwork. Federal executive direction, sector regulators applying existing law, and states moving independently. Colorado, California, others. Existing consumer protection and anti-discrimination law already applies to AI decisions, which people forget. Then Asia Pacific. China with rules on algorithms and generative AI. Singapore with its model governance framework. India with its evolving approach. Canada, Brazil, the UK, all developing positions. So here's the strategic point, and this is why the AI RMF matters. These regimes differ in detail, but they converge on the same underlying expectations. Know your systems, assess your risks, document your reasoning, keep humans meaningfully in the loop, build to a solid framework, and you're substantially ready for most of them. Chase individual regulations one at a time, and you'll never stop running. Alongside regulation, a standards ecosystem has grown up, and it's worth knowing who does what so you don't duplicate effort. Start with NIST, RMF, which is our subject. Voluntary, flexible, outcome-focused. It tells you what good looks like, not exactly how to get there. American in origin, but used globally. Then ISO 42001. This is a management system standard, cousin to ISO 27001. It's certifiable, which is the key difference. You can be audited and hold a certificate you can show a customer. NIST tells you how to think. ISO 42001 gives you something to prove. Around them sit others. ISO 23894 for AI risk guidance. ISO 31000 for enterprise risk generally. The OECD AI principles, which quietly shaped much of the vocabulary everyone now uses. IEEE work on ethically aligned design. So which do you need? Here's my honest answer from client work. They're not competitors. Most mature organizations run NIST AI RMF as their thinking framework and pursue ISO 42001 when they need external assurance. Think of it like this. NIST is the coach teaching you to play well. ISO 42001 is the referee certifying you played by the rules. You want both, and they're designed to fit together. So let's bring this home. Why a framework? Why not just handle each AI project as it comes? I'll tell you what happens without one because I've walked into it. A large client asked me to review their AI risk. First question, how many AI systems do you have? Nobody knew. Procurement had bought tools with AI inside. Teams had built models in spreadsheets. Vendors had switched features on. Their honest answer was somewhere between 12 and 200. You cannot manage what you cannot see. That's the first thing a framework gives you: visibility. Second, it gives you a shared language. Right now, your data scientists, your lawyers, and your board are describing the same risk in three vocabularies and talking past each other. A framework makes the conversation possible. Third, consistency. Without it, risk decisions depend on who happened to be in the room. Different teams, different standards, different outcomes. Fourth, defensibility. When a regulator or a claimant asks why you deployed that system, we followed a recognized framework and documented our reasoning is a genuine answer. We thought it seemed fine is not. And fifth, speed. This surprises people. Teams with a clear framework ship faster because the questions are known in advance rather than discovered at the last review. So let's pull the threads together. What should you carry out of this chapter? Number one, AI is different in kind, not just in degree. Probabilistic, data dependent, opaque, prone to drift. Those five characteristics break assumptions your existing controls quietly rely on. If you remember one thing, remember that. Number two, look upstream. Almost every failure we studied, the hiring model, the healthcare algorithm, wasn't a technical malfunction. The objective was wrong, or the proxy was wrong, or the data carried history nobody examined. So when you assess a system, don't start with the algorithm. Start with what it's optimizing for and who decided that. Number three, risk management protects value, it doesn't oppose it. Your job is to make yes possible. And number four, the regulatory tide is coming in, and it converges on the same expectations everywhere. Build to a framework, and you're building for all of it. Now, if you're looking for a detailed, structured course on this topic, with role plays, quizzes, and practice tests, our Udemy course link is in the description. And do subscribe to the channel, it genuinely helps. The YouTube playlist link is also in the description, and clicking it will give you the complete list of every video in this series in order. Next chapter, we meet NIST itself. See you there.